Hello, welcome to everyone in this video. This is our lecture number 15. You all know 14 lectures are covered. From lecture number 1 to lecture number 7, we discuss about the solution of the differential equation by Frobenius method. And especially we discuss about the legendary polynomial, Bessel differential equation and Hermite differential equation. And then lecture number 8 to lecture number 14, we discuss about the solution of the partial differential equation by the separation of variable method. You can see we discuss about the specially Laplace equation and the vibrational problem in one dimension, two dimension, and heat conduction problem solution also discussed in this lecture. So if you want to watch the previous two series of lecture, that is the lecture number 1 to 14, you can go to the description box, link are given there. In this lecture, lecture number 15, we want to discuss about the Fourier series. Total part of Fourier series we want to discuss in this lecture, and in the next lecture we will be discuss some problem which are will be asked in this question will be discussed in the next lecture. So I think you clear about the series of this total lecture. You can see we will be discuss this portion in this lecture, mainly highlighted the Dirichlet condition, Parseval identity, and all things about the Fourier series will be discussed in this lecture. So look at the syllabus of this University of Calcutta third semester physics honors. That is lecture number 1 to 7 will be discussed this portion, and lecture number 8 to 14 will be discussed this portion, and now lecture number 15 will be discussed. This is the Fourier series. Clear? So let's start. Actually, Fourier series says that is the Fourier theorem, which says that any periodic single valued non-sinusoidal periodic function. That means this is non-sinusoidal means sinusoidal means sine and cosine. Sinusoidal means sine and cosine. You know, I think you know that is the sinusoidal. Sinusoidal means sine and cosine. Sine function and cosine function is known as the sinusoidal function. And other than sinusoidal, that is called non-sinusoidal periodic function, can be expressed with the summation of sine and or cosine function. That means sine and cosine, or only sine or only cosine, can be represented any non-sinusoidal periodic function. That means you can see here that is a periodic function, and this can be represented as a sine and cosine function. You can see this can be represented like that, or you can see this is a square function, this can be also represented as sine cos. Okay, so this is the graphical representation, and we will be discussed that is in mathematical also this can be possible. That's a non-sinusoidal periodic function can be expressed as a sum of sine and cosine function. This is the Fourier theorem. For that you need to know about the periodic function. Periodic function means after a time interval this function will be repeated. So this can be represented like that, that is the function of time t is equal to function of time t plus t. That's mean this will be periodic function, because after a time interval this will be the same things will be repeated. This actually copied and paste like that. Okay, so this is actually periodic function, you know about this. Next thing will be know about the orthogonality of sine and cosine function. You know what do you mean by orthogonality? That's mean their integral product of total integral will be 0, and this will be mutual orthogonal. There will various variable, they when they are not equal this will be 0, and when they are equal this will be some constant. You know, for unit vector of x-axis, y-axis, and z-axis taken as I cap, j cap, k cap, then they are I dot j, I j dot k, k dot I will be 0. That's mean when these are two not equal this becomes 0, and when these are equal I dot I is the 1, that is the constant. So this is the mutually orthogonal property, that is when they are number will be greater than 2, then their product will be individual to another will be 0. This is the mutual orthogonal property. Okay, so I think you know about this thing. This is the recapitulation. And in case of the sine and cosine function, you can see that is for integration from minus L to plus L of cos function will be 0. Similar for sine function will be 0. You can do this integration, I think very easy. Just to put this limit, you can see that is the 0 for cosine function. This is also 0 for sine square. This gives you a value. For cos square this will be a value. like that. Clear? uh, this is the average value within a region of sine value, and average value of cos within a region will be 0, but average value of cos square and sine square will be presenting like that. And for the product of their two sine and cosine function, cos will be 0, sine will be 0, sine cos also will be 0. So this sine and cosine function will be mutually orthogonal to each other. That's the point, right? So you know need to know about the Dirichlet condition. Actually, any periodic function can be represented by Fourier series when they satisfy this Dirichlet condition. Without satisfy the Dirichlet condition, it is impossible. If this periodic function will be satisfy the Dirichlet condition, then it can be represented the Fourier series. Okay, and for your convention, you know, and also know about the non periodic function also be represented as a Fourier series by Fourier transform, helping of the Fourier transformation. So we need to know about the Dirichlet condition, because this condition is required to express any periodic function in terms of the Fourier series, right? So first condition is will be periodic. This is the main condition. Next one, the number of maxima or minima within this periodicity must be finite. There will be a finite number of maxima minima. You can see here, this is the periodicity. There is a single maxima, there is single minima. So there is finite number of maxima and minima. So this can be expressed as the Fourier series. But you can see here, there is a large number of maxima or minima. There is a large number of maxima and minima within this period. This is the periodicity. So since there is large number of maxima and minima, so this cannot be expressed as the Fourier series, right? Next point is the finite number of discontinuity. You can see here, there is a periodicity like that, and there is a 1 and 2 discontinuous. So within period there is 2 discontinuous, finite number. But in that case, you can see there is a infinite number of discontinuity. So within this period there is a infinite number of discontinuity. So this cannot be possible to express the Fourier series, right? Next, absolutely integrable of the function within this period. That means this function will be integrable within that region. This cannot be infinite value. This must be a finite value, right? So the integral value will be must be finite. Then you can see this will be expressed at the Fourier series. So I think clear about the Dirichlet condition. This is most important for this uh, Fourier series known, because without satisfy this condition, the Fourier series cannot be obtained. If this function satisfy this condition, then only the Fourier series can be find out, right? I think clear. Next, Fourier series and Fourier coefficient. So if any function satisfy the Dirichlet condition, this can be represented as the like that: a0 by 2 summation n equals to 1 to infinity an cos 2 n pi x by b minus a. B and a is the limit, and bn 2 pi nx by b minus a, where a0, this is the Fourier coefficient, a0, an, bn, these are the Fourier coefficient, where a0 is 2 by b minus a to b f of x dx, n is the 2 by b minus a to b f of x cos 2 pi nx by b minus a, and bn equal to like that. So these are the Fourier coefficient which will be obtained from the Euler's formula, or sorry, this also known as the Euler's formula. This expression actually find out by Euler. So that's why this is known as the Euler's formula. These are the Fourier coefficient and this is the Fourier theorem. Clear? And this can be presented in the symmetrical limit. If this limit will be minus L to plus L, so A equals to minus L and B equals to L. If you put this A equals to minus L and B equals to plus L in this expression, you can see this is minus A and this is plus A, so this is 2L and this is 2L also, so this 2 to cancel out. So you will be get the expression like that: cos n pi x by L sin n pi n x by L, where A0 equal to like that A n B n. So in this expression, just before, in this expression, put these two things: a equals to minus L, b equals to plus L. You will be get these things, because this is will be frequently asked question. And there is another, that is when take this L value is L, sorry pi, when the value of L taken as the pi, this f of x can be represented like that. F of x can be represented like that. Okay, f of x can be represented like that. You can put this a equals to minus pi, b equals to plus pi in this expression, or you can put l equals to pi in this expression. You will be get the this thing. This will be very important because most of the question asked in this range minus pi to plus pi. That's why so we retain this as a expression. Okay, so I think clear about the Fourier series. Now know about the even and odd function and their Fourier expansion. Suppose f of x is even function. Suppose f of x is even function, then what will be the coefficient, Fourier coefficient? You can see a0 will be like that. Since this is even function, this can be written as like that, 2 into this. This is the formula of integration. Since this is even function, and you know cos also even functions, product of even function will be even function also. That's why this is also even function. But product of even function and this is the odd function, product of even function and odd function will be odd function, and for odd function minus a to plus a infinity integration will be 0. Clear? So in case of even function you will be get only a0 and an, b0 bn equals to 0, and you know even function is nothing but f of minus x equal to f of x. In case of odd function, that is f of minus x equal to minus f of x, you can see this will be 0. This even and sorry, this odd and even means odd function, this is 0. This is odd and odd, so this become even function, those this is the like that. So in case of even function, a0 and an exist, b0 bn equals to 0. In case of odd function, a0 an equals to 0, bn exist. Clear? So this is the even function or odd function. If you find out the even function or odd function very beginning, you can eliminate this constant. In case of even function, bn equals to 0. In case of odd function, a0 and an equals to 0. Next portion, some example. Give some example with the Fourier series. Fourier series. Suppose this function from minus pi to 0 is 0, 0 to pi by 2 is minus 1, pi by 2 to pi equals to plus 1. If you plot this graph, you can see minus pi to 0 is 0, minus pi to 0 is 0, 0 to pi by 2 is minus pi, 0 to pi by 2 is minus 1, and pi by 2 to pi is plus 1. So this is the representation of this function. You can see there is discontinuous, but discontinuous is finite number of discontinuous, and the maximum minimum will be finite. That's why this can be represented at the Fourier series, right? So this satisfy actually Dirichlet condition. This satisfy the Dirichlet condition. That's why we can represent this function as the Fourier series. Okay, so from Fourier theorem, we know this function will be a0 by 2 summation n equals to 1 to infinity an cos nx plus bn sin nx, where a0 is nothing but 1 by pi minus pi to plus pi f of x dx. Put this value f of x, you know in this region minus pi to plus pi, minus pi to 0 is 0, 0 to pi by 2 this is minus 1, and pi by 2 pi equals to plus 1. Just putting this value, integrating, you can easily find out this is 0. Next, an will be like that, and this also expand in three portion. This portion is 0, this is minus 1, this is plus 1. Integrating, putting this value, you can easily find out this is the an, value of an. Similarly for bn, same thing, integrate will be fragment in three parts. This portion 0, this is minus 1, this is plus 1, and finally just integrating, you can easily find out this solution. Total is like that. You can see when n equals to even, this is plus 1, so this is 2. For n equals to odd, this is minus 1, so this becomes 0. So depending on n, even or odd, bn equal somewhere 0, somewhere some value. So this is an, this is bn, and a0 equals to 0. So if you put this value in this expression, you can see this is value of an, this is value of bn, and expanding like that. This is the solution. Clear? For any query, you must comment in the comment box in this series of lecture. Next one, expand this function. This is a function you must to expand in this series, Fourier series, then express this as like that, infinite series form. Okay, so the same things, you can see this structure, the graph of this structure will be like that. That is from minus pi to 0 is 0, that means this minus pi to 0 is 0, and after that 0 to pi equals to x, 0 to pi equals to x, like that, 0 to pi equals to x, 0 to pi equals to x. This is the periodic function, this will be the periodic function. Okay, So if you want to find out this Fourier series, you can see this Fourier theorem says like that, where a0 equals to the like that. If you put this value of f of x within this region, because within that region this is 0, so we will take this 0 to pi, will be get this thing. For an equals to similar process, you will be get this one. And for even and odd, you can see for even n equals to 0, for odd there is some value. In case of bn, something similar process, you just put this value f of x within 0 to pi, because minus pi to 0 is 0, and just taking this integration, the bypass integration, and put this value, you can easily find out, right? So you will be obtain the a0, an, bn, put this expression, and just expand, you will be get like that. Okay, so you will be obtain this portion smoothly. Now you need to find out this expression. For that, you just put this value of x, put this value of x, and in such a manner such that this problem asked in this question will be obtained. Okay, so here we take x equal to 0. You can see if, this is 0, this is pi by 2, x0 is 1, so this become like that, x0 sine 0 is 0, so this total become 0. So finally we got this coefficient will be like that, that is pi square by 8. So this is the solution of this question. I think clear. Next portion, that is a complex representation of the Fourier series. That means we already expand this Fourier series in terms of sine function and cosine function, but you know the sine function and cosine function can be expressed in terms of this, sorry, you know that is the sine function and cosine function can be expressed in the exponential function. You know the sine nx equal to nothing but e to the power I nx minus e to the power minus I nx by 2, and sine nx equals to e to the power I sin x plus e to the power minus I sin x by 2i. So if you put in this expression in sine and cosine, just put this cos value and sine value in terms of the exponential, and then separate out in terms of power of exponential, in terms of power of exponential. You can see here e to the power ix a1 by 2 and e to the power ix b1 by 2i, e to the power ix an by 2i by 2i. Okay, so just common out, and you can see this taken as a constant, this taken as a constant. So this is the positive part, this is negative part, and these two combination we can write down this function as this exponential function or complex function like that, where cn equal can be find out like that. And this in the other interval, this is actually the interval will be minus pi by 2 plus pi. This is for minus pi by 2 plus pi, this interval for minus pi to plus pi, and this interval for minus L2 plus L and this interval as taken as A to B. Okay, so these three things I think clear. This is 2, this is 3. So this obtain in this interval, and just replace in this A to B interval limit. And for a minus L to plus L, just put this value. You can see actually in the first case we write down this one, then that, then that. So just reverse portion you can like that. Take an example. Obtain the complex form of the Fourier series of this function like that. So you need to find out the complex form. So you know this is the complex form of Fourier series where n equal to like that. So find out the C0. Just put this value of n equals to 0 and put this value of f of x from 0 to pi. So you'll be get half. For Cn minus pi to plus pi, same thing, you will be just integrating, you will be get this expression, and you know e to the power minus I pi n equals to cos n pi minus I sin n pi, and this is nothing but minus 1 whole to the power n, and this is 0. So for here we can write down this one, and for value of n equals to even, this becomes 0. For n equals to odd, this become like that. Clear? So the f of x will be the sum of this expression. Put this coefficient, you can find out this solution. This is the solution for this is the complex solution of the Fourier series. Okay, and you can just think this is nothing but 2i sin theta sin x, this is nothing but 2i sin 3x, 2i sine 5x. So put this value and take the common, you can see this will be the solution. And this solution can be also find out directly by the previous method. You can check this from the previous method, you will be get the same result where you use the complex variable from or sine cos from. Clear? You must check this in the direct method, means the previous method we just discussed. In this method you can find out this Fourier series will be like that, which is matches in this process. Next, this is an important things, that is expand of non-periodic function over a interval. That means a non-periodic function can be also expressed in the Fourier series. How? Suppose this is a non-periodic function, that means this is not repeated, where this is a non-periodic function. But we can imagine this repeated like that, this is copied and pasted somewhere here, and you can see this is a periodic function. So non-periodic function can be made a periodic function, and after that we can write down the Fourier series for this periodic function, and this is nothing but the solution of this non-periodic function also. And this non-periodic function can be periodic in this form or in this form or in this form. For that, this limit of periodicity will be 0 to L, but for this one and that one the periodicity will be 0 to 2L. So you can write down this is represented like that. This is periodicity will be L. For that this periodicity will be L, but in these two cases the periodicity will be 2L, because you can see this total portion will be actually copied and paste. In that case also this portion actually copied and paste, but at that one this will be the copied and paste. Clear? So I think clear that the non-periodic function also can be expressed in periodic function. Just copy and paste in this region, will we get the solution. Okay, take an example. Suppose f of x is x square within that region 0 to 2. So f of x square will be like that. You need to find out the Fourier series of this expression. Now you can complete this one and you just copy and paste. So this will be now periodic function. Now you can solve the Fourier series, and this solution will be satisfy this function also. So the function is f of x. So its Fourier theorem will be like that, where a0 equals to 1 by 2 minus 2 plus 2 f of x dx. F of x is x square within region 0 to 2, within region sorry, this is a total function, that's why minus 2 to plus 2, no problem. So this will be 8 by 3, and a n equals to like that, same thing, just taking the by parts and put this value. Sorry, you can see here when we put x equal to 0, this is 0. When we put x equal to 2, you can see this is n pi. So in both case this portion will be 0, but in that case you just taking another bypass method. You can see this will be when n equals to 2, like that. For x equal to 0, this is 0, and for this sine become cos, and you can see for sine 0 is 0. When to put x equal to 2, this is sine n pi, this is also 0. So only the remaining term will be cos n pi, and you know cos n pi is nothing but minus 1 whole to the power n, minus 1 whole to the power n, because cos n pi, put cos equals to 1, so cos pi, which is minus 1, put cos equal to 2, the n equals to 2 pi, that is 1, cos equal to 3 pi, that is minus 1, and so on. Clear? So this is the solution of this coefficient. And bn equals to 0, because this function is odd function, you know, sorry, even function. Since this is even function, in case of bn there is the f of x and sine nx. Since f of x is even function, so product with the sine, this become an odd function, that's why bn equals to 0. So there is no requirement to solve this bn in this process, right? So we obtain this an, bn and a0. Just put this value of this equation, you will be get this one, because bn equals to 0. So you will be get f of x will be like that. Okay. So in expand you can write down this or this solution. Now comes into the next part, that is the term by term differentiation and integration of the Fourier series. Okay. So Sometimes just take an example, that is the if wants to find out this is a x to the power 4, x to the power 5, like that, or simply x cube. So if you find out the this is x cube, you can see that in this process, bypass process, this will be enhanced. So when this will be increased in the 4 or 5, this integration will be very long. So reduce these three, actually we obtain these things, we can help these things, that is derivative and integration, actually we help us to reduce the efforts to solution of this equation where this in the higher order. Okay, so these are the actually the use of the Fourier series in the higher order, like that. So the Fourier series is integrable and differentiable. For that you need to satisfy this condition, that's mean the integrable within that region, and differentiation or integration must be converged within that region. So after integration or derivative, this f prime must be satisfy convergent, and this must be satisfy the Dirichlet condition. And the process used to calculate the Fourier series, complicated Fourier series, actually find out using this process. Take an example, find the Fourier series of this function f of x equal to x cube. We already discussed about f of x equal to x square. So using this solution of the previous, you can find out the f of x equal to x cube. Since f of x equal to x square is like that, we just obtain the previous solution. If you integrating the, you will be get these things, and just this can be a solution. This solution will be like that. So you can see here, this is a different in 4 by x 4 by 3x, because in the left hand side there is only x cube term, but in the right hand side there is x term. So this must be eliminated. This can be happen by this derivative of this expression, and just rearranging them, you can see this is 2x equal to like that. So put this in expression, that is 2x equal to this one, you can get this solution. Yeah, so this is the use of the derivative and integration of the Fourier series. That means the term by term derivative will be help us, or integration will be help us to solve the complicated Fourier series. Clear? If there is any doubt, you must comment in the comment box. Next question. Parseval identity. Parseval identity. Parseval identity says actually the relation between the Fourier coefficient to the function within that interval. So the average value of this function within that interval is nothing but a0 square by 4 half a1 an square plus bn square. For complex form, you can write down this will be like that, and pi for pi you can see, for minus pi to plus pi standard form, this will be 2 pi minus pi to plus pi f of x square equal to dx equal to a0 square by 4. Right hand side will be same, there will be not changes, n equals to 1 to infinity an square plus bn square. Okay, so this is the Parseval identity. This is the Parseval identity. It says like that. Okay, and this can be proved, you can just take this integration, you can easily find out the individual time interval, you know this will be the square form, and for square you will be get the half, and for non square you will be get this 0, right? Sin cos will become 0. Okay, take an example. Using Parseval theorem, find the Fourier series of x square, calculate like that. So the Fourier series of x square you obtain in the previous question, and now taking the f of x whole square over this interval, you can see this becomes 16 by 30, and this like that, you know. So put this value, and this is the theorem. Using this theorem, you can easily find out this solution. Okay, so this theorem is important to find the any series solution. Next is the application of Fourier series. So using Fourier series, you can obtain the finite number of discontinuous function, and the order of derivative not exist, whereas the Taylor series, actually in case of Taylor series there will be a derivative does not exist is not possible, but Fourier series can be possible where derivative does not satisfy like that. Okay, and Fourier series can be obtained a non-periodic function also, and Fourier vibration of the series and effective sound wave, and Fourier series used to solve different equations. So these are the application of Fourier series. Okay, I think clear, and in the upcoming video we will be discuss about the Fourier transform also. So before that, you remember these things, Fourier series, or revise this one again. This is your homework, you do yourself first. Question number 1, 2, 3, 4, 5, 6. Okay, so do yourself first. After that, if there is any problem to solve this question, you can go through the next video. In the next upcoming video, we will be discuss this problem and with some additional problem also. So I think clear about the upcoming video, content of the upcoming video. So this is all about me, and this is my contact detail. You can connect with me this Telegram channel, and this is my online platform, and this is my YouTube channel details. Go to this channel, you will get different physics related video and some mathematical video for the math general. If you have general portion for mathematics as a mathematics, you can refer to this video also. And like this session, if you learn something from this session, share this video to your friends, either he or she also get benefit from this video. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. So take care, we will meet in the next video as soon as possible. Thank you.